push the announcement?
Yes, please do so. Okay, so today we'll be talking about manipulating the DOM with first JavaScript directly and then do a little bit more advanced C3. It turns out that the camera went missing, so there's not a live stream. I'm recording my screen right now, and I'm not sure how good this will be, and I don't know how good the audio will be, but we'll try to upload this file to YouTube later for reference. But there won't be a live stream for sure unless the camera turns up and somebody brings it here. Anyways, so let's start with DOM manipulation. Last time we talked, in the last technical lecture, we talked about how we manipulate the DOM using D3. And now we will look at what is actually happening behind the scenes, because that's often quite useful to really understand. And so we've talked about the basics of JavaScript. We've seen HTML, and I already mentioned a lot about what is the relationship of the DOM to HTML. Anybody want to summarize that relationship? It's a favorite exam question of mine. What's the difference between DOM and HTML? Yeah?
HTML is just a string. The DOM is an actual data structure that has attributes for the.
Exactly. So the DOM is like a data structure that you can essentially, that the browser renders, and you can generate something that resembles HTML in the DOM dynamically. And therefore we can manipulate this with many different functions and methods. And so we'll take a look at this. I should say that people don't usually do a lot of DOM manipulations themselves. They with the vanilla API, they usually use a library. Unless you just need to do one or two little things, then the cost of importing a library is probably not worth it. So other libraries for manipulating the DOM would be jQuery or even React. And of course, there's always a MDN reference. And so the DOM lives inside an object in JavaScript that's called the document object. And here is this nice MDN reference page of it. So I would definitely recommend that you look at this particular one here in detail. Okay, so what can we do with this? Here we have a simple HTML piece here where we have a single div which says text in HTML. So this is what, let me zoom in, I think. Okay. So this is what we generate in HTML. Then here we can look at the document. So this is a console logging the document here. Okay, and so here's our document object. And so you see that this in the browser or in the console, if I print the document, it really looks like basically the DOM that I'm rendering if I use the inspector. But here I'm just inspecting this particular variable based on my console log dot here. Now in this line here, I'm using the document object that I just logged here that has a lot of methods to access any of its elements. And one of the methods is get element by ID. And obviously, what that means is retrieves an element by an ID. And this, of course, should only return a single element, since we were good HTML developers and have used an ID only for a single element. And so here, what we have now is we have retrieved in this main div this particular div here. So this is what's held in this variable at this point. I can log this div, and you can see that this is exactly what I expected here. And now, of course, I can use this div to create, or I can put something into this div. So for here, I'm creating a new paragraph. And at this point, this is detached. This isn't really attached to the HTML. I'm saying document.createElementP, so create a new paragraph that's stored here. And then new paragraph.append child document create text node. And so here, I'm within the, I'm basically saying, create a new text node and append this into the paragraph element. So here's some text in a new paragraph that was created dynamically in JavaScript. And then at the end, I have to append my paragraph to my div. And this is then the output of these set of operations here. Okay, so like just to recap, we have the get element by ID, we have a create element here, we have a create text node, and an append child function, which is defined on nodes and not directly on the document. Great, so we can of course use this to make more complicated programs. So here I have an HTML that does contain only this line again, text in HTML, and now I'm creating this output here where I've looped through something and then generated elements as we go. So pretty simple. Here I create a wrapper function where I create a div with text using some of the same functions as above. Then I retrieve my div again with get element by ID. Then I run a loop and attach a child. Attach a child to the div using my div with text function from before, and as input I simply provide the I, like here the index, and I multiply it by itself. And that results in like these numbers here. And then finally at the end I'm just like showing like here's what I like another way, or not another way, just doing the same thing again, just with like an element outside of the loop. And so here I'm adding like an X to this div. Okay, so that's fairly simple. We can also equally control attributes of elements. So for example, using styling and positioning. So like what I'm doing here is I'm creating this very beautiful rainbow colored text and the background, like the colorful text here. And we start out with just the H1 element, colorful text, and then we have a div element in our HTML. Okay, so how do we do this? We have this function div with text, which is essentially the same as before. But now we create like this text add function where we set the position and the color. And the text add function takes like the text and then X and the Y position. So I create in the function, I create my div with text. And then here I'm using the set attribute functions, and that kind of, I can use this for any attribute of any element. And I'm simply putting in like a style tag, and then like some positioning information, left, top, and then color. And here for color, I'm using the HSL, hue, saturation, lighting color model. And hue is our first variable, as we learned in the color lecture here. I'm simply taking the X value and use a modulo operator so that we have like a value between 1 and 255, and then 100%, 50% for saturation and lightness. And so this is kind of like what we get if we circle through the hues like that. And then I'm simply at this point here creating another loop where I create where I append the text, or where I create the text adds and then also append them. Okay, is this clear, or any questions at this point? Great, this is fairly simple. Now we can use JavaScript like 90s style and do some nice animations. So this is essentially the same thing as we just did before. The only a couple of the things we have to add here. Well, we have our new DOM element with the text. And here what we do is we actually add an update function to the nodes. So like here we are actually taking an object that already exists. And that's something that you can do in JavaScript and add a function later, right? This is because of this prototypical inheritance. Objects are always initialized. I can define functions on top of these later. And I'm saying node.update is this function, and the function takes a parameter like amount, how much I want to update it by. And then I have my v variable, which I simply add the amount to. Then I do like a basic, like here I'm creating the text content, which also updates based on v. And then I'm calculating positions x and y. Again, modulo operators, because 800 is my width and 50 is the height that I want to bin this in. So this is where we get those all visible and nicely like displayed on the screen. And then here I'm setting my styling positions as I did before. And so now I initialize this with 0. And then here I run a tick function. And so in this tick function, I simply iterate over the nodes and then update the nodes. And the trick here is that I have like a tick forever function that calls this tick function, but it like basically, and it also recursively calls itself. So here we have this window.request animation frame. And so what this does is it tells the browser the next time you're about to refresh, the next time you're about to render, please call this callback function here, tick forever. And that essentially allows me to do this kind of animation without like running like an endless loop. Yeah, that's basically the magic behind what's going on here. So like here I'm just initializing the nodes, and then I call the tick forever the first time, and then consecutively it's being called recursively. Okay. If we did this in the naive way, and like the result here is this like beautiful rainbow animation. If we did this with like the naive implementation where we simply ran a while true here, what would happen is that we would essentially like not see much because it would simply keep cycling and not wait for it to re-render, and eventually we would kind of like crash our browser. So I'm not actually uncommenting this here. Okay. Any questions? So this is, yeah.
Is the window object like in the document?
Yes. Yeah.
So why do you modulo one plus?
Which piece?
So you only fix modulo B, modulo one.
Yeah. That might not be necessary. But it's going to result in the same thing. Yeah.
The node.update function, what's the purpose of making that a function like that and not just calling all of this?
So basically here I'm telling, I'm kind of like, I tell my node, like if I want to change your position, this is whatever you have to do. And like this happens over and over, right? So every time this moves over a little bit, this update function is called with the new number that you can see. Like here we're at 80,000 right now. And so this is kind of like the parameter that we put in here. I could do this once and just simply call off this stuff, but that like I couldn't recycle that as easily. Okay, so there's a lot more to the standard API, but I really was just meaning to give you kind of a glimpse on what it looks like. Now we will look at something that we also use from the standard API, but that we actually frequently use, is events. So basically, at this point, we have like up to this point, we have only like created self updating stuff, and we haven't really caught any events or done anything specific with it. And so now how can we react to user input and build interactive programs? And that's what we'll look at next. And so not surprisingly, as in any programming language, I have some kind of event system that happens when I like interact with an element on the screen or on the canvas. So here what I'm creating is I'm creating 3 buttons, like button on click, button ID, and then a div, so 2 buttons and a div. And what this looks like is I have my click me, no click me, and can you also click me text here. So if I click this, I get an alert here. Yes, it's me, button 1. If I click this, I get an alert, you chose me, button 2. And then, of course, one thing is that buttons are kind of like convenient, but because they kind of like symbolize something to a user, but all of the events that are defined on a button are equally definable on any other HTML or DOM element. So it doesn't have to be a button. I can simply click on this text here, and that will simply say, see, you don't have to be a button to be noticed. So how does this work? There's 2 different ways of how you can hook this up. Well, there's many different ways, but I'll talk about 2 different ways. One is I can, in my HTML, directly reference a function. So I can say button on click is equals message me function. So this is basically telling the element, the button element, that on the click event, this is the function that you should call. So this is how we implemented the first button here, the click me. The second button, I actually don't provide a direct reference to any function. I'm simply saying button ID my button. So there's no hookup here. What I'm doing later is I'm retrieving my button with the standard API document get element by ID my button, and then I set the onClick function. And the onClick function here like exists. I'm basically overriding it here with this anonymous function that throws out this alert here. And the message me from earlier is defined up here. And then finally, like I use the onClick definition again for the div message. So this is the same thing. So I can now click all of those independently, and I have those two different ways of hooking them up. Okay. So we can equally, like there's many other events. So for example, we have an onChange event. So here I am creating like this drop-down box here where I have 3 fruit, pear, apple, and plum. And what I want to do is if I click any of them, I actually update the text down here. So again, very simple, apple, like plum, apple, pear. Okay, so how do we do this? It's actually like the same principle, right? I'm creating this selector, this drop-down box. This is the select. I give it an ID drop-down. I'm giving it the 3 options. The value here is what I use to identify it, and in this case, it's the same as the string that's actually displayed. And then for the second option, like notice if I look at this Unload, just after I created it, apple is my default here, and that is simply defined here by adding this selected attribute that is not, there's no value, it's just selected in this case. So I have option selected value apple, so this is my default selection. And then I simply have a div here where I say my favorite fruit, and I have a span with an ID that is empty. So like this is empty initial, like before the JavaScript is executed. And then I'm retrieving here with the standard API, retrieve the fruit span, and then set the inner HTML of the fruit span to the value of the dropdown. So I retrieve document got element by ID, retrieve this dropdown by its ID, and then by running the dot value is what is the currently selected value is what I get back from this, and that is what I'm setting to this inner HTML. And now, so this has kind of like renders our first initial, like when we initialize it. And now we also need to implement how we handle events so that we can actually see what happens on a change. And here I'm simply hooking up the dropdown with an onChange event, a callback function here in this case. And for that, I'm doing the same thing as above. So I'm doing document get element by ID, fruit, inner HTML. And here I'm actually using events carry like their target as a variable, that dot target, that's the object that triggered the event. And I'm simply retrieving that the target, this is the drop-down box here, I'm retrieving its value. But I could have also just copied and pasted this here. Like this is what I do here, and those two work just the same. Okay. Other useful events that you might encounter is onload. So when you load a page, on mouse over, on mouse out, on resize, and so on. And then finally, of course, this isn't just HTML. I can do this with SVG as well. So here I have a bar, and every time I click this bar, I change its color and make it grow. So it's a little hard to see me clicking, but trust me, I'm clicking. So I initialize this with like this simple rectangle. So you see this, the original blue rectangle here. And then I'm retrieving the get element by ID my bar. So I'm retrieving this rectangle. And then I'm setting here like a new value, the underscore data underscore is 0. And what I choose here is completely up to me, right? Underscore underscore data is just something that I picked because this is also the variable that D3 uses internally, but I could call this like my data point or whatever, right? So this is just a convention. It has nothing to do with how this really works. And then I'm hooking up the onClick function. Here I'm defining a set of colors, like 4 different colors that I'll be cycling through. Then I'm retrieving the rect from my event, which is the target of the event. Then I'm retrieving the current width of the rectangle. And then I'm setting the width, I'm increasing the width here by 10. And then here I'm setting the color, the fill, by simply using like rect.data modulo 4. So because I have exactly 4 elements in my array here. And then I increase rect.data at the bottom. And this is kind of like what allows me to do this. Okay, so as we see, this is just consistent between how it works with SVGs, how we can handle events for SVGs, as we can do that for HTML. Great, so any questions about the standard API before I move on to a little bit different topic? Yeah.
Question on the resize event, does that trigger you to drag your box and change the size? Does it trigger over and over and over again, or does it trigger on the end?
That's a good question. I'm assuming that it will resize within some bounds, but I don't know actually. You would have to try it out. So it's not gonna resize it's gonna resize once you slow down or occasionally. Yeah.
As far as best practices, is it better to do direct reference to a function or through?
Yeah, that's a good question. I would basically say if you have a very simple relationship from button to this one function, then I would just write it in the button directly. But if you have maybe something more complicated going on and a couple of different listeners, then I would probably hook it up later. It also depends a little bit on where you think the hookup happens, right? If you have a piece of JavaScript where you hook up all your events, that might be a good point to see what events exist and what buttons they react. Whereas if you have it in some HTML, it might be a little bit less obvious where each thing is being called. I guess the other advantage of doing it in JavaScript is that it's a little bit more robust to refactoring. So yeah. Great. So you've already done this here, but I just wanted to go over it quickly because your homework 1, you could simply just open an HTML file in the browser because you didn't read any data in. But as soon as you need to load a file, you can't actually just open an HTML file or a JavaScript file anymore because that is a security precaution so that you can't load stuff from a local computer. So what we need to do instead, if we have something that is set up of multiple files, is that we have to run our stuff in a web server. And there's ways around this. Locally, you can still pass some parameters to your browser so that it allows you to run or to type past the security exception. But this isn't standardized in any ways, and in practice, you always want to run a web server when you develop. And so there's basically many different ways of running a web server and hosting your own stuff locally for development. I'll show you 2 ways. The very simple one, that if you have Python installed, you can use the simple built-in HTTP server. This is what you can use to develop. Or alternatively, you can run stuff directly out of an IDE. But let's look at the Python example first. I simply go into a command line, and then here, let's see. Lectures. Okay, so here I have a couple of D3 HTML files, and then if I were to run, I have Python 3 installed in my computer, I'm simply copying this command over, run this command here, and now I'm serving on 000 port 8000, and I can use this kind of URL here to access this. So I have my different HTML files, and then I can basically click on any of them and they will execute here. Okay, so this is like one way of running a web browser. And so you do this either for Python 3 or for Python 2. In practice, if you're building something that is a little bit bigger, I would recommend that you use like a server from an IDE. Like I use WebStorm, but lots of people nowadays use Visual Studio Code. But what this essentially does is, like, I've opened up PyCharm or WebStorm here, and I could then simply right-click on any file here. Like I have a D3 HTML file here, and then I can say debug d3.colorscale. And we'll look at this example later, but now I'm basically running this web server directly out of PyCharm. And so what's nice about this is that I can now also debug this code, right? I can set a breakpoint here. And if I were to rerun this, it would actually drop me to that breakpoint, and it would let me inspect the variables where I'm currently at. So here you see like my data, my local variables, and so on. And so I can simply hover over any of those elements and see what is their current value, right? And so this is like a process that I'm sure many of you are familiar with, but it's just like makes your life much, much easier. And then I can like do things like step over individual lines of code and see how stuff has changed. And so in this case here, you actually see the values. Like this is not actual code, right? This like lightweight text is just a WebStorm's way of like directly in line showing me the values of each of those variables. And so that makes kind of development much easier. Of course, you can do a vanilla text editor without any like features like that and run the Python web server. But this is just a way of like how you can like conveniently debug elements. A quick other way of debugging something, let me remove this breakpoint and then continue execution here. Another way of debugging that you can do very easily, and also for any website, is you can simply look at the sources in Chrome. So here I have the source open in Chrome. And this is the D3, so I need to go into this file here. And now I can also set a breakpoint directly here in Chrome. And so if I now click run, Chrome will do much the same as an IDE. And so I can inspect any of those variables here directly, like what are the values, like height is initialized with 400 and so on. So that's kind of like a pretty fancy debugger, even if you don't have the code. And so that's kind of like complementary to simply logging stuff to the console, right? So that you can actually develop a little bit more complicated projects. Any questions about this? Great. Okay, so let's move on. Now I want to do more advanced D3 next. So we'll start off here with simple things that we did already, and then we'll end up with a pretty fancy bar chart where we use nested data, different scales, and that updates correctly. Okay, so let's recap quickly. We talked about selections in D3 and how we can use the results of selections to like manipulate, add stuff, or even style stuff. So here we start out with the simple HTML. There's no styling, but then I run a D3 select statement here, d3.selectAll, and select all the spans that are children of P. I log this selection. And then I can style it with color steel blue, and so you can see that the elements that are in the span here are now in blue. The third one doesn't have a span, so there is no blue one here, but 1, 2, and 4th paragraph do have a span contained in it. So this isn't like something new, but what's what we should kind of like, what I just quickly want to recap is the relationships between the selections and what you like and how they look behind the scenes. So if you like, if I print the selections here, I do get this selection object. Let me just rerun this. I do get the selection object, and what I see in here is the selection object contains the groups, like basically the selections, and then here I have the explicit node list, and I can look at these span elements and what they exactly are, right? So there's a lot of like variables that are defined for such a DOM element, but this will also contain things like your inner HTML that is actually rendering what is being displayed within that span if you have something. But at this point, I don't have anything in here. So we can also see that we have the groups array contains the selection with the node lists, and we can also see the selection object have other fields like parents and so on. What is this field here? What do you think?
It's the parent.
The parent, yes. Remember, this is kind of like, if you think in classes, this is the parent class, but of course in this case it's the prototype object. So this is like we know that the span or the parent object, the prototype of this particular one here is what you see here. So if you have any functions that are not defined on the lower level object, you can always look at the prototype. So now we do the data mapping. What I have here is like this example from before that I mapped to these like 3 data values. As we talked about last time, I'm simply running selection.data with those 3 elements. So this here we can now log the so we initially log the selection. So we have our in our groups we have our 3 rectangles, and then we log our data. And then in this case here we have in our groups we will have the rectangles, and the rectangles will also have our data object here mapped to it, right? This is what happened if I connect because D3 bound this particular value to the first rectangle, and then I see that here, and so this is what I'm logging here. And then we do something with the selection. I'm setting an X and a Y position. Remember this data-driven styling. I have D and I. Here it's really the first and the second parameter. I use this anonymous function with the arrow notation, and then I use I to position this particular bar in the Y direction. For the width, I'm doing a direct mapping between the data and how wide it should be. That is simply D arrow D. So that means I have a function with the variable D and has a return value D. And that's kind of the very short, concise notation for that. And that's all there is about this, just like how you can see those data elements. Okay. If we look at the properties of the selection, we can also see now these separate enter, exit, and groups here. So, like, not surprisingly, enter and exit are the enter and the exit selections. And the groups is kind of like the merged selection or the update selection. So that's kind of like the groups is the thing that you essentially mostly want to manipulate. And we can see all of those elements. And just to recall the relationship between enter, update, and exit. So if we bind data to elements on our DOM, there's 3 different cases. We have elements, we have data elements that don't map to any of the elements in our selection, right? That would be the elements that are in the enter selection. Then we would have elements that map to existing data that maps to existing elements. This would be our update selections. And then we have elements in our selection that don't have a representation anymore in the data, and that are exit selection. And we can treat those 3 separately with like many different ways. Usually we want to do enter, we create stuff, then we merge it, and then we style it. And then for exit, we typically remove it. here, like we do like a simple example as we had it last time, we simply start out with an empty canvas and we create those elements by doing like this here by adding the data element and then running data.enter. And on this enter selection here, I'm running append for the rectangle and then doing all the styling here on the appended elements. Okay. So now, like this is what the enter selection looks like before I've actually done an append, right? This creates a generic enter node. And this enter node at this point isn't a proper HTML element. It's really like, as you can see, much smaller. There's only like a couple of fields. So this is our generic enter node. It has the data bound to it. And it has a parent. But other than that, it doesn't yet know what it is. So we have kind of like these phantom objects that are not yet properly initialized once we like in this enter selection, and only after we like make it into a proper HTML element will this be like moved to be to be like this element that we can actually then render in the DOM. So like what we did here is we only used the enter selection, so this wouldn't be robust to updates. What can we do if we want to do updates? So here's an example where I have like a bar chart now that I created from scratch with 6 rectangles, and now I can switch between different data sets. So what do we have to do to achieve that? So as I said, there's an empty SVG, nothing else in here. Here I'm simply switching between 2 different data sets. So either like the one here or the one that is passed to the execute here. So this is one of the 2 data sets that is associated with a different button. So that's all there is about this. And then here I'm doing my data join. I'm handling my exit selection by removing it simply. I handle new elements by simply appending a rectangle and setting it to the right class. So I want them to be of class bars. Then I do my merge so that the bars now contain both the new elements and the old elements. And then we do the styling. And so we do this for the updated elements and for the new elements in bulk. And this is kind of like what I need to do to be able to do this kind of thing. This handles all the updates correctly. And if I add elements or remove elements, that's also handled correctly. We talked about an alternative last time. That's kind of like a new feature, the selection join. And the selection join is like a great shorthand for stuff where I really like want to do basically just like handle enter and update, but don't do anything fancy with any of those. And so the selection join does exactly the same thing, but it is convenient if I kind of want to use default behavior. Default behavior is adding new elements from the enter selection and removing elements that are in the exit selection, and then updating all of the update selection with whatever happens beyond. And I do that by calling bars.join, and the parameter here is the kind of the HTML element that I want to create in case there is an enter selection. So this by saying rect here is what happens is whatever doesn't exist yet in my selection, they should be bars. And that's what this, or this should be rectangles, SVG rects. So this is what the parameter here means. And then I don't actually have to take care separately of enter or exit or update, or I don't have to merge. So this is kind of like the convenient way if I don't need to do anything specialized with my enters and exits. So this works just as well. And if you want to create just this functionality, this is the most concise way of writing it. There are ways of handling updates and exits explicitly with the join. I personally, I think, prefer to just, like in that case, if I have to really handle them separately, just use the classic update paradigm and use the join when you just need the simple case, which is probably very often sufficient. So, okay, is this clear, like what the join and enter and so on, all of this does? Any questions?
So join replaces enter and merge?
Enter, exit, and merge. So it simply defines a set of default behaviors for enter and exit. Enter is simply append new elements of whatever you pass into the into the parameter of the join. Exit is simply remove. Yeah.
Is there a particular reason why you selected based on the CSS class instead of the HTML element?
Yeah, usually that's better practice, right? Because you will, if you create a big visualization, you will have a lot of rectangles and circles around. But by selecting it based on the class, I know exactly what I'm actually selecting. So if I have like a rectangle for, let's say I wanted to create a background rectangle here, just to give me some like contrast, not white, then I would also select the background rectangle, but I don't want to select that background rectangle. Yeah.
When you call dot class, what is the second parameter?
The true, so you can actually set this to false, then it removes that class. That's very convenient if you want to use class-based styling for something like a selection or a hover. Yeah.
In the book, it said that you could select using both the element and the class or ID. Is that a better way to do it, or do you prefer class?
It depends on what you select, right? I would always, if I select a button that is unique on my website, I would use ID. The button might have a class that is to style it in some way, but I wouldn't use the class button to hook it up to an event, because I want to hook it up specifically only this one button to this one particular event. If I want to select multiple rectangles and style all of them simultaneously, then I would use a class. So really the distinction is like the semantics of the ID, like a unique object on my page, and the class, a type of object on my page. And I very rarely actually use element selectors because they are just way too generic, right? In a practical program, you always want to select either class or ID. Like what you see often is that I select an SVG because I usually only have one SVG on my page, so that's fine. But in many projects, you might have multiple SVGs in your page, and then even that would be problematic. Okay, we talked about transitions, and so what we can do with transitions is something like this. We start out with like a single rectangle in gray. We click run. It fades it in and merges it and makes it bigger and changes color. And then we have a graceful way to handle changes in dataset as well. And so this is all quite easy to do because these transitions are essentially super cheap. I'm like really basically what is new here is really just the like on exit. I start out with opacity 1. I run transition for a duration of 3 seconds. I style it, and this is kind of the style at the end of the transition, right? So everything that I do before here is to style at the beginning of the operation. Everything that I do here is to style at the end of the operation. And then what will happen in the 3 seconds of the transition is a linear interpolation between those two states. And so I'm basically making them like transparent. And then after they are transparent, they're actually removed from the DOM. So if we look at this in the inspector, so we can see now we have a single rectangle here. If I click run, you see that like how this updates, right? So you see the numbers change. And now we have all of these different rectangles. And then if I click next dataset, you see how the numbers change again. And then finally it removes like many of those rectangles. So you can really see all of the intermediate states here with the inspector. What are the other transitions that I'm using here? I'm using essentially, like in my enter, I initialize my bars with a width of 0. But I'm positioning them already at the right place. So this is what happens if I like click on next data or on run. You see that those elements don't move into place, they simply grow out of the right place. And that's because I have positioned them correctly in enter, but I have given them a width of 0. And then in our updates, we simply say transition duration for 3 seconds. And this here now we define only the final style. And here we basically say width D is D. And then we set the fill and opacity accordingly. And that's the whole trick. So we only have added a couple of lines and get this super nice animation. We don't have to think about any interpolation states ourselves. Yeah?
Is it possible to have multiple different transitions on this selection? So say transition shape over 3 seconds and color over 2 seconds.
Good question. Do you know, Kieran? Two different transitions simultaneously? Yeah. Yes, actually, yeah. Just naming them and not using the inline style, like the inline continuation, that you can simply have your selection and apply 2 transitions. Yes, that makes sense. Okay, so what do I want? Like I've had only simple bars here, and I didn't have to do anything more complicated. What happens if I want to do something like this, where I have bars with labels, right? So what are conceptually 2 ways how I could achieve this?
On your selection, you could append the text that's set by the value of the data.
Yeah, that's kind of like the basics. And then I could either position the numbers here by like moving it over in Y and then moving it over in X, or I could create a group that essentially does my Y positioning and then only worry about the X positioning for the label. And so both are like, those are 2 strategies. In practice, the grouping strategy is a little bit better because these are actually also meaningfully grouped together, right? They belong together. The label belongs to the bar. And so what I'm doing here is and this is like a naive example, and I'll show you why. Like this here doesn't really do the update correctly, but I'll just like show you how this whole thing with the grouping works, and then we can talk about why this is broken. So we again switch between the data sets. What we now we select all and bar group which don't yet exist and bind the data to this new bar group class. So we have we have an enter selection with uninitialized elements. So then we say bar groups.enter append G's, and so now we have defined that those are G's and that they are of class bar group. Okay. Now we say to these enter bar groups, this is the selection that I now have. Here append a rectangle, and then I style this rectangle, and then add a label to this group. And so for this label here, I actually don't have to, like both for the bar and for the label, I don't have to do any positioning, right? The positioning is like, I'll do the positioning later for the group globally. The only thing that I have to do for the text is I have to move it over so that it appears next to a bar. And this is what I'm doing here. I'm simply doing a translate by D plus 5 pixels, which I use for padding. So this is like the white space between the text here. And then I'm setting the text, the content of the text is actually the data itself. And the dy, I'm simply like setting to bar height divided by 2. So this is like just my, how do I align the text exactly. I handle my exit, I merge them, and then here is where I position the groups in Y. So up to this point, they've all been like essentially not at no position, but here I'm actually translating them based on I multiplied by like a bar height variable. Okay, and so this kind of like works for enters, but it doesn't work for updates. Anybody want to guess why? Like one hint that you might see is that I do a lot of styling before the merge. So like I do, like I create all of these rectangles and set them in like and style them and so on. All of that happens before I do the merge. And that's usually an indication of that something will only work for the enter selection, not for the update selection. There's a little bit more subtle problem here. If I were to print this, which I actually do, but here's a screenshot of it, is what you will see on an update, my data will, of the group, like I have the data bound now 2 or 3 times. I have the data bound once to the group, once to the rectangle, and once to the text. And if I run an update with this code before, it will correctly update the data of the group, but it will not propagate that update down to the rectangle. So you see the rectangle still has like an outdated data element here. And so the way to fix this is simply to take a little bit of a different approach here. Is like I'm basically here taking care of like entering elements. I'm appending my rectangles. I'm kind of like doing it minimal, like in minimal way with 0, so no data-driven styling here. Then I append the text, and notice I'm appending empty text elements. I'm not setting anything about the text. I'm taking care of the removing elements. Now I do the merge. Then I move this whole stuff, the groups, I move them to the correct Y positions. And then I reselect. So I'm saying bar groups dot select rect. And so now basically I'm taking what I had in these groups and running selections on them. And by doing that select here, I also get like any updates propagated down directly to the rectangle. And then I can style this, and similarly for the text. And the result of this is that I can now, like I did some transitions as well, I can now like update this in a nice way. Notice also how I picked the transitions for the text so that they don't move along, but it's removed immediately, and then it's faded in place as the bar approaches the part, its final position. Now the data is bound to rectangles at the right point, because I kind of like bar groups.select propagated the data down. So generally, this is like the much better paradigm, right? Because I'm doing all of the styling after the merge one time instead of doing like updates or styling on the enter selection. Okay, any other questions about this? Great. So like one big thing that we haven't talked yet about is scales. I've always picked data sets. Like if you look here, the data values that I had were something like 127, 256. These are convenient dimensions in pixel space. So now data isn't always like that, obviously, right? If I do have to do some transformation, and you had to do these transformations for your homework 1 manually. Like the Anscombe is quite that data set, isn't really scaled such a way that you can actually like display it well. And we can do this like in a much more efficient way with code, of course. So here's a data set that doesn't work in swing coordinates. I have 0.3, 0.01, and 1.5. And if I run this, I get this measly bar chart here. So you see like there is a bar, but it's really, really tiny, right? It's 1 pixel. So what can I do? But generally speaking, I just need like a function that maps an input data set to a derived data set D prime, where the input data set D is basically my data domain, and D prime is my screen domain, like my pixel domain. And what that function is can be anything, right? It could be just simple as like a linear scaling. And that would work here. I could just take those values and multiply them by 50, and then I would have like a usable value. So I can do that manually. Here I'm creating a scale function. My scale function here, I'm simply like returning input multiplied by 500. So that would be a manual implementation here. And for the width here, I'm taking the data that was bound and then scale it by then run the scale function on D, on my data element, and then return that as the width. So question, why don't I just multiply all of the data elements with 500? Exactly. You can do pretty complicated things with scales and these scale functions, but you still want to keep track of your raw data because you might want to display it in a label, or you might want to use a different scale function later. So it always makes sense to bind the raw data and then only do scaling as you need it into display space. So that's a way of doing this manually, and this isn't particularly hard, right? I can write these functions myself. But of course, D3, this is kind of where D3 really, and this works, right? So I have now my values here, and I get these nice big bar charts. But there's, of course, many different ways of scaling data. So we have logarithmic scales, we have power scales, we have discrete scales. We can also scale, we can also map data to color scales, or we have ordinal data or temporal data. So sure, we can write all of these functions ourselves, but D3, Mike Bostock has done it all for us. And so we can simply use D3 scales. And there's many different types of D3 scales. Here we look at the most simple one. That's the scale linear here. And what you need to think about is that each scale in D3 has a domain and a range. And the domain is what I said, the D, our data space earlier, and the range is our D prime, our pixel space. And so here, we simply say dot scale linear. That's a linear scale. We set the domain to 0 and D3.max. And I could use any other function to calculate the maximum value of the data array here. This is just D3, because this is very common. Max and min has a max function here. So I run D3 max, which gives me the biggest value. So what this tells us, this is our data domain. So we start at 0, we go up to data. Why don't I do D3.min here? Why do I do 0?
Your min just be right at 0. Or you can't see the difference, it's not 0.
Yeah, exactly. So if I did D3.min here, my smallest bar wouldn't even be visible, right? And I would have started my scale at some value where my lowest bar is. So in a bar chart, I usually want to start at 0. And so I'm not using the minimum, but I'm using 0 here. And then I map this to 0 to 700 pixels. The rest here is fairly simple. The only thing that I do here is to call my scale functions just as before, x scale of d, to set the width. And then I get this here with our linear scale. Now I could very easily replace this with a log scale. But one thing that I have to do, because log of 0 is undefined, I have to put in a non-zero value here. I missed a comma, I assume, somewhere. I think it doesn't matter, but yeah, maybe you're right. Yep. So that was the problem. So now we have a logarithmic scale here. If I do 0.01 here, I will actually still be able to see my first bar. Okay, so there's many different scales. I'll talk about some of them later. One thing that happens frequently is that you have an outlier in your data set that kind of ruins your scales, right? You have whatever. If you think about people's income, you might have 1 billionaire in the room that simply doesn't show any variation between the rest of the people in the room. So what we can do here is here I'm kind of drawing a rectangle which is supposed to be our screen canvas, and if I have one bar that extends that canvas, it will just render beyond that. And this sometimes is a little bit annoying, and so one simple way to kind of mitigate this is to do a clamp. If I do .clamp true, then I set here my domain from 0 to 1.5, but I do have a value here that's 2. So that value is bigger than my domain. And so any values that now exceed the domain are shown as being exactly of that size. So this is like a tricky thing to do, right? Because now I can't actually tell the real value of this anymore. So what in practice I would have to do is to like also render some like symbol here that this is a broken bar and add labels, maybe make it a different color and so on. But with clamping, I can simply say, if you have bigger data values in your input, simply do not exceed your domain. Then we can use color scales, and color scales are super convenient. So here is a simple example of like a bar chart where I have a redundant encoding by size and color. I use red for negative values, blue for positive values, and I use saturation for the magnitude of those values. So you see that these are the small ones are almost gray, whereas the big ones are very dark. And so this is like super easy to do with color scales. So I have my data set here, which is like a mix of positive and negative values. Here I set up my X scale, which is, in this case, between min and max. So not 0, because I have both negative and positive values. And then I set up my color scale. And I say D3 does scale linear, domain D3 min to D3 max. And for range, I simply put in, instead of numbers here, I put in color values. I'm putting in an array of color values: dark red, light gray, steel blue. And those are color values that HTML understands. And what this color scale will do is, I put in a domain here with 3 values at my neutral point because I have a diverging color scale, right? And so it will map dark red, the first one, to the first one here, to the minimum, then light gray to the 0, and then steel blue to the maximum. And I can do this with like as many elements in my array as I want. And that's how I get this nice color scale. Because I have now positive and negative values, I have to be a little bit more careful in how I position this stuff. So I either start at the value of D for X if D is negative, or I start at 0 if D is positive, and this is what this does. And then the width is simply the absolute difference of D and 0. And I'm working here in scaled coordinates. And then finally, for color, I'm simply setting style fill to color scale of D. And color scale is what I defined earlier. And here I just pass in my data value. And that's all there is to this chart. Any questions? Great. So now what we want to do is to we labeled some of our bars, but like what's also very common to understand really what's going on in the data is to draw axes. And of course I could draw my axis manually, but D3 provides us with the ability to simply throw in an axis like this here. And so here we see that we have values from minus 1.2, even though the minus here is a little clipped, to 1.2. And so what do I have to do here? And like not surprisingly, axes work well together with scales. So that's another reason to use D3 scales instead of your own custom scales. I have here, like the rest of this is the same as before. I have an X scale. Then here I create a new axis, and that's like a D3 function, and I have a couple of different axis functions. I have D3 axis bottom, axis top, axis left, axis right, and depending on where I want to position it. And then here, this is the key thing here. I'm telling my axis what are my scales. And I'm simply saying x-axis dot scale, and then I put in the x scale that I defined earlier here. Then this stuff is just the drawing that I did before. And then at the end here, I append a G, and on the G, I then call the x-axis. This is kind of the syntax to simply append the x-axis to this G element. The x-axis here is really a function. And then this is what I get. So that is a lot better because we have an axis, but of course it's not perfect. So what can I do now? I can do this here. I will basically here I'm drawing a background rectangle, and then I create the axis to like perfectly align with this background rectangle. I'm doing some styling on them. Also notice that I have like chosen my like the axis to be nice in layout. So I have from minus 1.4 to plus 1.4. The ticks are evenly spaced and so on. And so we'll take a look at how that all works. First, the styling for the axis is what I do here. I have like I create a class .axis, and for .axis, the path elements and the line elements, I make it a green stroke. And for the text, I make it a serif font with font size 14. Then I have like, I'm doing something I haven't done before is I do padding here, right? My SVG is bigger than this, but you notice that earlier I had cut off the minus here because I basically started at the very margin of it. And so I need to kind of avoid this cutting off, I need to do some padding. And so I do this padding here, 25 pixels. So here's my background rectangle, the gray one that I applied before, and then here everything else is happening in here. One function that basically gives us these like nice and round axis scales is the .nice function for scale. So I'm saying d3.scale linear and do everything as before, and then say .nice, and that simply does its best guess at like what is a reasonably nice scale, and it extends this a little bit if it needs to. Then I can, here I create my x-axis and I apply this now nice scale to it. Here I'm doing some kind of like padding, transformations to take care of the padding. I'm moving like everything over by the padding in x and in y. The rest of this is standard. And then I do my append for the axis by running svg append g, then say .classed, and this is what I defined this axis class before in CSS, true. And then I move it over by padding and height so that the axis here is at the bottom. So all of this is fairly like just code, nothing new except for the nice piece that is new here. That just makes the scale, like instead of what we had here, like minus 1.2 to 1.25 or something like that, it's now like symmetric from minus 1.4 to plus 1.4. I can do like manually set ticks if I want to. And here, like I have way too many ticks, but that does work. So every 40 pixels here I have ticks. Great. And so I have 10 minutes left and only one example, but it is a big one. So we'll go through this code now. There's what do I want to do with this? I have now a couple of things that we haven't talked about. We have only at this point, like in our homework, we actually used objects as data values. But up to this in the lecture, we've only used directly like numbers out of arrays. And so here we use a little bit more complicated data structure for this visualization. We have bars that represent some products like apples, bananas, plums, bread, cereals, beer, and wine. We have like the tonnage, or like how much of this was sold in weight. And those have different types. So we have fruit, we have groceries, and we have like alcoholic beverages. And so all of this is styled in a data-driven way. And then I have some interaction in here that I can either sort by type, sort by product, or sort by the weight. So there's a couple of things in here that like I want to kind of like teach you guys about, but the most important thing is really key functions on the data mapping. So what do I mean by that? Notice that if I update here, like between weight and product, these move nicely, right? And that's kind of like a supernatural way of doing that. But if I just did it the way we usually do it, and like this is the magic code here, but I want to show what happens if I don't use the magic code. if I just do this, as we did it before, I simply bind the bars to the data, then this is fine, but what now happens is not great, right? So I'm basically, things are like animating, but they are not animating in a sensible way. So there is no logical consistency between the elements. So if I switch to products here, suddenly, like I have wine at the bottom here, and then if I switch to weight, I have cereals at the bottom here. The animation, there is some animation happening, but it is not sensible. And so the problem here is that like D3 doesn't know by default how to move these things around if we don't tell D3 what the unique element of the object is. And so what I need to do here is I need to provide the D3 data binding with a key. Where is it? So, and then this is what I do here. I'm saying dot data, and then to that, I have a second parameter now. And this second parameter is kind of like our key function. Here we specify what makes something be the same over different time steps, over different update phases. And for my product, I should have said this earlier. This is how this data structure looks like. I have an array of objects with product, tons, and type. And clearly what is the unique identifier, the ID here, the key, is the product name, right? This is what we kind of want to be consistent. So, and not the tons and not the fruit, not the type attribute. And so we can tell D3 objects of that same shared key are supposed to be the same thing by putting in this key function here where we return d.product. Remember, d is our product, like the whole object, and it has the product, the weight, and the type in there. And we tell it, hey, look at d.product in this case to identify objects that are identical over different time steps. And so that is kind of like the most important piece about this here. There's a couple of other things that but before I move to other stuff, is this like any questions about this? Okay, so this is like an important, like a common problem initially if you start out with D3 and you have some very funky animations, like just make sure that you are using the right key function. Okay, so what other stuff did I want to talk about here? Like how to access data and objects. We've kind of did this implicitly. How do we sort data? How do we properly deal with padding in an SVG? We haven't talked about a special type of scales. This is for categorical data, scale bands. And then how do we update a scale? Okay, let's look through this just in sequence. So here I have my data. Then I was lazy and just like copied my types here. I could have just also gone over this data set and extracted the types from that. I'm using here an accessor function for max for the object so that I simply, I don't have to do access d.tons all the time. And then I define a margin object. I say like margin top is 20, right is 30, bottom is 30, left is 40. I'm initializing my width from and subtract the margins to the left and right, and similarly for the height. Then here we create a master G element and move everything by the margin. So like I have here D3.select chart. This is like my background or my basically what I have in my HTML here, the SVG. And then I append a G that I move over by the margins using a transform translate here. The rest here is actually fairly obvious. This here is new. And this is scale bands. And these are super convenient for if we want to do something like ordinal scales. So in this case, I'm actually not manually calculating the positions of these bars here, like where they are and why. I'm simply telling, like using a scale band to let D3 automatically calculate the position of each bar and also the padding. And so that's what I use the scale bands function for. Where are we? So I'm simply like here initializing it with range from 0 to height and a padding of 0.1. And then here I initialize my Y scale. I set my Y scale to the domain of the of my product values. So here I'm using data.map because I really like this domain really depends on just the weight and not on anything else for the Y scale. Then here we do the key function, like that basically guarantees us object consistency. And then here we package each data item into a G. And then set this to be the bar group, similar to what it did before. And then we move this over by our Y scale. So for the D dot product, so we can simply retrieve that here. And here is our scale band, the Y scale. So that we created earlier up here. So here is our scale band. And so this is how we like position this bar at the bottom here. And also notice the syntax that I'm using here. Instead of using like string concatenation, I'm simply using this like backtick here, the dollar bracket symbol, but I could have just done plus Y scale, D dot product, plus brackets, and so on. This is just another way of expressing this in JavaScript. This here is fairly obvious. And then here, I use this Y scale again to position the labels correctly. So I say Y scale.bandwidth, and that gives me kind of the height of the bar. So that's kind of like a static variable that's independent of the data, just by knowing this, the Y scale knows how many elements there are and kind of divides it, like adds the padding appropriately, and then gives the bandwidth of the height of the bars. And I'm saying like I'm actually using this here to position my label right in the middle. I'm using a text anchor at the end. This is just like so that this stuff here is really just about positioning the labels correctly. I do a transition here. Now I add the rectangles, and the height of the rectangles is the Y scale.bandwidth. And again, this is this automatically by this scale calculated height of the bar. I apply my color scale. The color scale uses like 3 different colors based on the data types. So I initialize the color scale up here. So it's a D3 scale ordinal. Takes in as domain our types. These are the 3 different types. And I'm using as a color range, I'm using a predefined color range from Color Brewer. Color Brewer accent 4. Like there's a couple of different accent versions. That's the range that I'm using here. Well, this is just the animation. And then here we call our X scale functions on the weight, the d.tons. So here I'm just moving, like this is what happens after I sort. This updates the position. And then the rest of this code here is really just how do we do the sorting? Like how do we, like what are the sorting functions for these different values here? And I'm simply doing I'm hooking up an event, like listening to the change of the checkbox. I say D3 select, this is the sort select checkbox. Here I'm using the hashtag because it has an ID, of course. And then I'm saying on change, then call this callback function. And then this here is really just like the active one is the active type that I care about. And then here I'm really only defining the data dot sort. And as you remember, by default, it would sort it lexicographically. But of course, lexicographically for an object isn't really defined. So I have to retrieve the object name. So this is what I'm doing here. Like I'm switching over this active, like a.active, and well, this is my comparison for lexicographic sorting. And then if I had, like, if this is for type, and if I had weight active, my sort function should be based on the weight. And if I had product, I have lexicographic sorting. Okay, this is like all there is to it. It's like a longer example, but I think these individual elements are like fairly accessible, and then you can create a chart like this that does all of these animations nicely. Great. So, any questions before we wrap it up? Cool. And see you guys on Thursday.